So we will so after the Illumina sequencing reads, we will get the after the sequencing we will get the output is in the FASTQ format. Let's look at what the FASTQ format look like. For each read, it will has 4 lines. The first line is the ID of the sequencing read. And usually for paired end read, you will have /1 or /2 to tell this is the first mate or the second mate from the read of the paired end reads. And the second part is the sequence itself, SAGT. And the third line is some separator which are not important. And the fourth line is called quality score. Which is tells you what's the probability of that nucleotide is the right one. Yes.
So is that score based on the clusters?
Yeah, for Illumina, you can see that for each cluster, if the red signal is not that strong, you might say, it's not. I'm not very sure it's an A, so we will give it a lower score. And the quality score is represented by the favorite quality, that is the minus 10 times the minus log 10 probability. And to convert this number to the real probability is since these are just computerized English words, it's called ASK2 code, and you minus that to 33. And if that number is like 10, we will see that base pair is like has a 10% chance of error. If that number is 20, then that base pair has 1% chance of error. And here is the list of possible quality scores. The left one is the left one means worst quality. And so since we have quality scores for the reads, we can just tell how good our data set is. So we have 3 kind of scenarios. If we see a quality of a read is bad, how do we deal with that? We can either throw out the read, or we can just trim out or just remove the base pair that is very bad. And if all the reads in the samples are very bad, then we might want to just ignore that sample. And if all the samples from our experiments are bad, then we might ask the sequencing center to do the sequence again. So there's the most common use to quickly obtain the quality analysis result is called FASTQC, which I really suggest to do that before you do other analysis. Just run FASTQC and see how good the data set is. And here are some results, output from FASTQC. So the left figure shows currently we have 50 base pair reads. What's the distribution of quality score on each base? For good one, we will see all the qualities are very top. And for poor quality data set, we will see many of the reads with low quality, near here. And we also just noticed that for Illumina sequencing, no matter how good it is, we will see the quality will slowly drops towards the end. That is because when the cluster extending, some of them might be not synchronized well, and the chemistry might go old. So in the later cycles in Illumina sequencing, we will see the drop of quality. And for each read, we can compute its average quality. And here is the histogram of how many of the reads has a high average quality. And if that peak is towards the right end, that means many of the reads has very good average quality, then that means this data set is good. Otherwise, this data set has too many problematic reads. And also, since the reads can start at kind of ideally can start at any position on the genome, so we will expect that each nucleotide will show up about the same uniformly start at on the each position on the read. So, but on the right figure, we see that there is a bias. That means some position will not, the read will only start uniformly on the genome. Then that means there's some problem. And Illumina sequencing knowledge also has some GC bias issue. That means they tend to more difficult to sequence the reads if it has more GC content. So the FASTQC will also generate this plot. On left, it shows like, on right, that shows there are too few reads has GC content. That means there are some issues. And based on this just straightforward plot, and then you can tell how trustworthy this data set is. Any questions? Oops.
Sometimes it doesn't show up. You just have to try it. Yeah.
Oops.
Yeah, you stop the recording.